10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff. Go SpaceX. Go Spainsat in G1.
Vehicles pitching downrange.
Stage 1 propulsion is nominal.
T plus 30 seconds, Falcon 9 has successfully lifted off from Complex 39A at Kennedy Space Center. We can hear the characteristic rumble as the first stage heads into space. We're throttling down right now in preparation
Power and telemetry nominal.
for max Q. Good call out, power and telemetry nominal, reports avionics.
Falcon 9 is supersonic.
And we have throttled back up to power.
Max Q.
And we've heard the max Q call out. Continuing on the timeline, everything looking good. The rocket typically will need to go 17,000 miles per hour horizontally in order to get into orbit and avoid being pulled back down to Earth. To help go from vertical to horizontal, the first stage performed a pitch kick just after liftoff, about 10 seconds into flight, or what's also known as a gravity turn. The engines gimbal a small amount, and that slowly turns the first stage from going straight up to going horizontal with the help of gravity, and eventually we will be roughly horizontal to Earth as we achieve orbit. Now you can track the progress to orbit by keeping an eye on the left side of your display. That's showing the first stage velocity and altitude, and then we'll have displays for the second stage as we get past stage separation. Now we're going to have coming up in about 30 seconds the start of the typical 3 quick events. Main engine cutoff, or MECO, you'll hear the call out. We'll shut down the 9 Merlin engines on the first stage. The pneumatic system, the stage separation pushers, will then push the first stage away from the second stage for stage separation, and the MVAC-D engine will ignite, and then fairing separation. For now, let's listen and watch for the events.
Main engine cutoff.
Stage separation confirmed.
MVAC ignition.
And there you heard and saw those events that happened back to back to back. We had main engine cutoff, stage sep, and second stage engine start number 1, SES-1. Right-hand side, you can see the altitude and the velocity of the second stage. So far, I want to remind folks who might be waiting for it, as we talked about earlier in the webcast, the first stage will not be recovered today. You may have noticed that we removed the landing legs and the grid fins to decrease the mass of the stage. That'll provide the performance needed to put the 6 metric ton spacecraft into orbit. The legs and fins can be used on other boosters. But now we want to say to the first stage,
Fairing separation confirmed.
Fairing separation on time. And for first stage that is on its way back to Earth, not for recovery, farewell, and we thank you. Now the fairing halves that you just saw separate from around the Spainsat NG-1 spacecraft, we'll be attempting to retrieve those halves once they fall back to Earth using our recovery vessel Bob. Now the fairings will orient themselves as they come back down with gas thrusters for entry into the atmosphere, and as they near the ocean, each fairing half uses a gas-powered deployer to release a parachute. The fairing computer will send commands that steer the fairings to the ocean landing, where the recovery vessel Bob will attempt to recover them. Now we've got a few minutes until our next major event, SECO-1, which is where we'll shut down our MVAC-D engine on the second stage in the parking orbit.
Stage 1 FTS has safed.
Coming up on 5 minutes, everything continuing to look good. You can see the orange-red glow of the niobium alloy nozzle extension on the second stage engine. Very standard for the MVAC-D engine. Five minutes, everything continues to look good. Now you'll notice the speed continuing to increase on the display for stage 2. That speed is obviously increasing. That's because the acceleration is going to increase throughout the burn. The thrust of the MVAC-D engine, just over 220,000 pounds of thrust in vacuum, stays constant during the burn. But as we burn off the propellant, the mass is decreasing. And so for those who remember force equal mass times acceleration, if the force is constant but the mass decreases, the acceleration is going to increase. For this first burn, the stack will be doing about 3.8 G's acceleration as we get to SECA 1. T plus 6 minutes, continuing to look good on the second stage. Spainsat NG1 attached to the top of the second stage. We'll see some views from the forward-looking camera.
Vehicles on a nominal trajectory.
A little later on. The GNC, the Guidance, Navigation, and Control Engineer, calling out the nominal trajectory for the stage. Six and a half minutes into flight, continuing to look good on the burn. Next major event's going to come up a little bit after 7 minutes. We should hear a call out of terminal guidance on the second stage as we begin to get ready for shutdown at T plus 8 minutes and 1 second.
Stage 2 is in terminal guidance.
There's the call out from GNC. Second stage flight computer is now moving into a state where it's preparing for that second stage engine cutoff. We're calculating the velocity required to get to orbit. You have to understand how fast you're going horizontally as well as away from the Earth. And then we have to come up with the commands that are going to go to the actuators so that we can command pitch and yaw to make sure that the second stage aims itself, so to speak, to achieve the desired orbital parameter. Now, final velocity for this first burn is aimed for about 7.5 kilometers per second. That's going to be just under that 17,000 mile an hour figure we need for a low Earth parking orbit. And 7.5 kilometers per second, that is the rule of thumb for the velocity you need to get into an Earth orbit when you're launching eastwardly, for example, out of Kennedy. Shutdown of the MVAC, we're going to wait for guidance to tell us how the orbit looks.
Nominal orbit insertion.
And confirmation, nominal orbit insertion. We're through second stage engine cutoff number 1, SECA 1. We're right where we want to be in orbit. Now, the second stage, and we've got another nice view looking forward from the payload attach fitting up at Spainsat NG1. We'll have more views as we go through the webcast, but for now, we're embarking on a coast phase on the second stage, spacecraft still attached. Following this coast, we will relight the MVAC engine for a second time. That's going to happen around T plus 26.5 minute mark. And then about 4.5 minutes after that, at T plus 31 minutes, we will actually get to spacecraft separation. For that, we're going to halt the live commentary for a while. We'll be back in about 16 minutes at T plus 25, but we'll leave you with the visuals from space. Waiting right now for the last seconds as the flight computer counts down to the ignition of the engine. Ignition of the MVAC-D engine. Now this burn's going to last about 67 seconds. That's typical for a geostationary mission. If you're watching the speed gauge on the right-hand side of the display, you're going to see that we're going to add about 2,500 meters per second to the velocity of the second stage, which is still carrying the Spainsat NG-1 payload on top. Now during this burn, as we continue burning off the remainder of the propellant, the acceleration will reach 4.8 G at the end of the burn. This is about 1 G more acceleration than we had on the first burn of the second stage when we had a lot more propellant on board. Engine now throttling down, decreasing the loads on the spacecraft as we're coming up, and we have SECO 2.
Nominal orbit insertion.
And there's the big call out for the day, nominal orbit insertion. Second stage in its second burn has put the spacecraft onto the desired trajectory. You can see right now 400 kilometers, 440 kilometers in altitude. We're headed to an orbit much higher than that. Next up, we're going to have separation of the second stage, of the Spainsat NG-1 spacecraft. We've got a couple of minutes before that happens. We'll come back with live commentary at about T plus 30 minutes. T plus 30 minutes, 32 seconds. Everything continues to look good. Welcome back to Spainsat NG-1 mission coverage. Had a great mission so far. We're less than a minute away from payload deploy for our customer, ISDASat. Now today's satellite will be placed into geostationary orbit at 29 degrees east longitude. A second satellite known as Spainsat NG-2 will be placed in the geostationary position at 30 degrees west longitude later this year. And the Spainsat satellites will replace the existing Spainsat launched in 2006 and the XTAR EUR launched in 2005. The view right now looking up from the camera on the second stage mounted on the payload attached fitting. You're looking at the bottom of Spainsat NG-1. And we're waiting for payload deploy.
Spainsat NG-1 deploy confirmed.
Avionics engineer calling out successful deploy. You can see it on the screen. Springs pushing the second stage and the Spainsat NG-1 spacecraft away from each other. And with that successful deploy of Spainsat NG-1 satellite, it begins its journey to its final destination. With that, that's going to wrap up our coverage for today. All of us at SpaceX want to give a big thank you to our customer Isdesat. We also want to give a shout out to the Eastern Range Kennedy Space Center and the Federal Aviation Administration for supporting today's launch. And as always, thanks to all our viewers for logging on and your continued support. Be sure to follow us using @SpaceX on X for mission updates. I'm John Innsbrucker. We'll see you again soon.